Hello guys, welcome back to my YouTube channel. I hope you have already subscribed to my channel and went through all my previous videos. And today we'll be starting with a new video. Myself Chandana, I am from Sri Venkateshwara College of Engineering, pursuing third year in Electronics and Communication domain. In today's session, we will be discussing about the subject microwave and antenna. Let us see what is the topic we will be covering in this particular session. Scattering matrix for H-plane T junction. Before going through this particular topic, what is meant by let us see what is meant by waveguide T. A waveguide T is a three-port device that can be used to either divide or combine power in waveguide system. It is a it is formed when three waveguide tubes are connected in the form of English alphabet T. This is where its name is derived from. As you all can see, the waveguide junction, which is shown in this particular figure. There are two types of waveguide T's, that is H-plane waveguide T and E-plane waveguide T. In today's session, we will be discussing about H-plane waveguide T. Let us see what is known as H-plane waveguide T. H-plane waveguide T. When the axis of the side arm of waveguide T is parallel to the flow of magnetic field H from port 1 and is perpendicular to the flow of electric field, then the T is called as H-plane waveguide T. As you can observe, the arm with electric field and magnetic field. An H-plane waveguide T's can be thought of as two-way in-phase power and divider. That is, it is additive in nature. When two input signal are fed to port 1 and 2, then output at port 3 is in phase and additive when the input is fed to port 3. And the signal is split into two equal parts that are in phase at port 1 and port 2. This is known as H-plane waveguide T. Now let us see what is meant by scattering matrix. An H-plane T junction is formed by attaching a simple waveguide to a rectangular waveguide which already has two ports. The arms of rectangular waveguide make two ports called collinear ports, that is port 1 and port 2. These are the collinear ports called port 1 and port 2. While the new one, port 3, is called a side arm of H arm. The port 3 is called a side arm or H arm. This H-plane T is also called as shunt T. As the axis of side arm is parallel to magnetic field, this junction is called H-plane T. As you can see in the diagram, the side arm is parallel to the magnetic field, then the junction is called as H-plane T junction. This is also called as current junction as the magnetic field divides itself into two arms. The cross-section details of H-plane T can be understood by the following diagram. This is the particular diagram. Let us see the characteristics of H-plane T junction. The first characteristic is because of the plane of symmetry, power fed into port 3 gets equally divided between port 1 and port 2. As you have seen in the figure, port 3 gets equally divided between port 1 and port 2. Therefore, S31 is equal to S32. Let us assume port 3 is perfectly matched. If it is perfectly matched, then we consider it S33 is equal to 0. And for symmetric property, we know that Sij is equal to Sji. We write the matrix for X It is S11, S12, S13, S12, S22, S13, S13, S130. Because S1 here you can see S21 is equal to S12 and S12 is repeated in the place of S21 and S23 is equal to S32 is equal to S31 is equal to S13 and in the place of S23, we have written S13 and even in the place of S32 and S31, we have given the same name labeling as S13. From unitary property, we know that matrix S into conjugate of matrix is equal to unity. We have to prove this unitary property by taking the conjugate of this particular S matrix. Hence, we will get unity matrix, identity matrix, that is diagonal elements are 1 and rest of the elements are 0. Now let us consider row 1 and column 1. As we all know, to find the determinant of the particular matrix by solving each row and column, we get the value of S13, which is 1 by root 2. To get further equation, we'll consider R3, that is row number 3 and column number 2, where that is S13 and S11 conjugate plus S13 S12 conjugate is equal to 0. We'll compare equation 4 and 5. By comparing, we'll get to know that S11 is equal to S22. And from equation 7, we can substitute that S13, you can take S13 common so that S11 conjugate plus S12 conjugate is equal to 0. Hence S12 is equal to minus S11 conjugate. When we remove both and we here will remove both conjugates. By using equation 9 and 6 in 4, that is substituting equation 9 and 6 in equation 4. So S11 whole square plus S11 whole square plus 1 by root 2 whole square is equal to 1. Hence S11 value will be 1 by 2. Hence we know S11 value, we have been known that S11 is equal to minus S11. S12 is equal to minus S11. So hence S11 value will be 1 by 2. Minus and minus will get cancelled here. So S11 value, we know S12 value is also known, S13 value is also known, S22 value is also known. Hence, these values will be substituted with respect to the matrix S. Here, we will be taking particular condition, that is matrix B is equal to S matrix into A. That is B1, B2, B3 into S is equal to S matrix into A1, A2, A3. Multiplying both row and column, we will be solving each B1, B2 and B3. Let P1 be the output microwave power coming out of port 1 and P2 be the microwave power coming out of port 2 and P3 be the input microwave power applied at port 3. Then we know that P3 is equal to P1 and P2. That is equal to 2P1 is equal to 2P2. As we all know, P1 is equal to P2. Ratio of the powers P1 and P2 expressed as 10 log to the base 10 P1 by P3 is equal to 10 log to the base 10 P1 by 2 P1. That is equal to 10 log to the base 10 1 by 2. That the value of this particular expression will be minus 3 dB. That is 3 dB down power comes out of port 1 and port 2 when power is fed into the HR, that is port 3. This will be about Tee Junction. Thank you for watching my video. Please like, comment, share and subscribe.